Hello everyone and welcome back to my channel. In today's video, we'll dive into an essential technique for simplifying complex resistors network. A Y delta transform or delta Y transform that we show also with delta Y or Y delta transform is the topic that we are going to cover in this lecture and the upcoming lecture. We also look at the T and pi network, T to pi network or pi to T networks, and we explain how they are related to the Y and delta. But before that, we should start with this first question. Why we need to use this transformation? Sometimes when analyzing the circuit, you come across a group of three resistors that are not neither in series nor in parallel. Look at this circuit. If you look at R3, R2, and R2 and R4, there are neither in series nor in parallel, same as R4, R5, and R6. So, and simplifying this circuit with the traditional method is impossible. Therefore, we need to do some kind of transformation. One of the useful one is transformation between delta to Y or Y to delta transform. But before we do so, we should know what is the Y and delta itself, data network. The Y network is look like a Y, and it has three resistors, consists of three resistors, each connected from a central node to one of the three outer nodes. Here I have a central node, and which one leg of my resistor is connected to this central node, and the other leg is connected to the outer node. We also may heard about T network. T network is exactly same thing as Y network, but with a different representation, meaning that one leg of each resistor is connected to the central node, while the other one leg is connected to the outer node. What is the delta network? In the delta networks, each resistor connected between two outer nodes. Look, resistor RC connected to two outer nodes. This is resistor RB. Sorry, this is resistor RB. This is also connected to two outer node. This RA is also connected to two outer node. And similar things, we call it delta network, and similar things for pi network. In the pi network, we have RC between two outer nodes, RB between two outer nodes, and RA between two outer nodes. Now our aim is to do the transformation from Y network, from delta network, which we show in blue, to Y network, which we show with red color. Now, assume that we have these resistors which are connected in the Y transformation. Okay, I redraw quickly the Y transformation. So I will have resistor here. I call it this one as R1. I call it this one as R2. And this is R3. And I assume that this is my terminal 1, this is my terminal 2, And for now, assuming that I'm not interested in other terminals, just terminal 1 and 2. And I want to see what is the equivalent resistance in terminal 1 and 2 when they are connected in the Y format. So obviously, if I want to take care of terminal 1 and 2, I can see that the R1 and R3 are in series, R1 plus R3. And if I interested to see the same resistor network on the same terminal for the delta network, I can redraw my delta network. I know that I have RC, I have RB, and I have RA here. These are connected to terminal 2, here 3, here I have terminal 1, and here I have terminal 4. So if I only consider the terminal 1 and 2 exist, then what is happening for finding R1 and 2 in delta format? I can see that RB and RC are in series, and these two in series are parallel with RB. Therefore, I can write RB parallel to RA plus RC. And I can write this one as RB product of RA plus RC over RB plus RA plus RC. So I can write this one as RA RB plus RB RC over RA plus RB plus RC. Yes. Now, since these two terminals, regardless of their way that the network, I mean Y on delta, they must be equal. Therefore, I can say that R12 is equal to, if I write it in terms of Y network, it is equal to this. And if I write it in the delta network, I can write as RA, RB plus RB, RC over RA plus RB plus RC. And I call this equation as equation number 1. Similarly, I can do for other terminals as well. Assume that I'm going to write for the other two as well. In order to save the time, I only write the final answer. The final answer would be similar things. So I can say that, for equation 2 and 3, you can do the similar things. I may interested to finding the resistor, equivalent resistor between terminal 1 and 3 in the Y network. It is like R1 plus R2, and in the delta network is going to be equal to RA RC plus RB RC over RA plus RB plus RC. So this is RC, yeah, equation 2. Also, I can do R for the terminal 3 and 4, R3 and 4, which equal to, on the Y transform, it is R2 plus R3. And if you do for the delta transform, it's going to be equal to RA, RB plus RA, RC over RA plus RB plus RC. And I can call this one as equation number 3. Now I can play with these 3 equations in order to find R1, R2, and R3. What can I do? I can subtract the third equation from the first equation. Subtracting R3, 4 from R1, 2, I can write this one as R1, 2 minus R3, 4. For the left hand side, subtracting these 2 is giving me R1 plus R3 minus R2 minus R3, and subtracting the third one from the first one in the right hand side, it should give me, since we have the same denominator, the common denominator, I have R1, RA, RB plus RC, but over numerator I have RA, RB plus RB, RC minus RA, RB minus RA, RC. RB, RB is cancelling each other, R3, R3 is cancelling each other, therefore my simplified version of this equation will be R1 minus R2 is equal to RB, RC minus RA, RC over RA plus RB plus RC. Now I can call this one as equation number 4. I can add equation number 4 to equation number 2. I can add these 2 together. Then what we have over here, so I can say that, yes, I can say that R1 plus R2, which is plus R1 minus R2 on the left hand side, is equal to, again I have the common denominator, RA plus RB plus RC, but what I have there, I have here RA, RC plus RB, RC plus RB, RC minus RA, RC. This is cancelling each other. What I will have 2R1 is equal to 2RB, RC over RA plus RB plus RC. Or I can simplify, R1 is RB, RC over RA plus RB plus RC. This is my R1. So I can look at my transformation figure. So I can see that what is R1? R1 is here. If I want to find R1, R1 is product of RB and RC product of RB and RC over the sum of all resistors. So I can get a pattern here which says that each resistor in the Y network is the product of resistor in the two adjacent delta branches. So two adjacent delta branches of R1 is RB and RC, which you use it in the numerator over the summation of all three resistors. Meaning that if I want to find R2, what should be the value of R2? R2 should be the two adjacent delta resistors of close to R2, which is RA and RC. This is going to be RA, RC over the sum of all resistance, RB, RC, and also I can find R3 as two adjacent of R3, it is RB and RC, RB and RC over RA plus RB plus RC. So in that way you can find the transformation of these two. So thanks for watching and see you next time.